Today we'll solve some more problems involving the Pythagorean theorem. Yesterday we had two problems, numbers 9 and 10, and if we look at them, they are similar, that they both are right triangle problems using the Pythagorean theorem. But if we look closely at them, we see they're a little different. In number 9, we're given the legs and we need to find the hypotenuse. And in number 10, we're given the hypotenuse and a leg and we need to find a leg. So to simplify this, to solve these problems, we can think of these as either an addition or a subtraction problem. So when we need to find the hypotenuse, which is the biggest side, we're going to add the square of the two legs together and take the square root. So let's look what that looks like. So in this instance, we have a leg 35 and a leg of 50. So 35 squared plus 50 squared equals the hypotenuse. So once we write the equation, we can go directly to our calculator and type in 35 squared plus 50 squared equals, and then just take the square root of that number, which is 61. So this will reduce a lot of the writing. So that's when we knew when we're finding the hypotenuse, we're trying to find the bigger side, though, so we're going to add the two numbers together. Now in the other example, we know the hypotenuse, we know the biggest side, so we need to find a smaller side. So we're going to subtract. We're going to rewrite our Pythagorean theorem where we have c squared minus a squared. So here we have c squared minus a squared, and that will give us b squared. So let's look at our calculator once we've written our equation. And we have 40 squared minus 16 squared. 40 squared minus 16 squared equals, and then just take the square root, which is 36.7. So this is a more direct way, less writing, but we're still using the Pythagorean theorem. So let's try a few more examples. Number 1, a computer monitor is labeled according to the diagonal measure of the screen. If the screen is 12 inches wide and 9 inches high, what is the length of the diagonal? So it's always good to draw a picture. So I've drawn a picture for you, and you go ahead and solve the problem. All right, so I filled in the numbers. I know that the two legs are 9 and 12 inches, so I'm trying to find the hypotenuse, and that's the bigger number. So I'm going to rewrite this as an addition problem. I'm going to say 9 squared plus 12 squared is equal to c squared. And now I'm going to go directly to my calculator and type in 9 squared plus 12 squared. 9 squared plus 12 squared. And I'm going to take the square root. And that's 15. So the missing side, or the hypotenuse, is 15. So C equals 15. Number 2, Sarah lives 4 miles north of school. Aaron lives 7 miles west of school. What is the straight line distance between their houses? So go ahead and try number 2, and I started by drawing a sketch for you. And when we fill in the numbers, again, we see that we are given the legs and we're trying to find the hypotenuse. So we're going to say 4 squared plus 7 squared equals the hypotenuse. So it's going to be an addition problem, so I'm going to go straight to my calculator. 4 squared plus 7 squared equals, and I'm going to take the square root, is about 8.1, we'll say. So C is approximately 8.1 miles. And number 3, a 15-foot ladder is leaned against the side of a building. The base of the ladder is 5 feet from the building. How high up the building does the ladder reach? So here's a little sketch to get you started. Go ahead and try number 3. So here I filled in the numbers. Now in this instance, I know the hypotenuse. And I'm trying to find a leg, so I need something smaller. So I'm going to use a subtraction problem. So I'm going to say 15 squared minus 5 squared is equal to b squared, or the other leg. So I'm going to rewrite this as a subtraction problem, and I'm going to go right to my calculator. 15 squared minus 5 squared equals a number, and I'm going to take the square root. So about 14.1. So B equals about 14.1 feet.